Welcome to the video. My name is Pushpinder Gill. So today we are going to do a set theory, right? In which we'll be discussing what all aspects does this topic has. So this is my email address where you can send me your valuable feedback. So let's go ahead and get started, right? So first of all, let's read this question out, right? That how many positive integers less than 100 are either divisible by 2 or 3? So many of us will be saying, oh, what kind of question is this? Is it algebra question, progressions questions? So the first step that you should take while seeing a question is to recognize that question. Which topic is it from? Because once you do that, half of your job is already done. So if you see these guys sitting over here, okay, this guy says, okay, damn it, the teacher did not explain that kind of question. But you have to understand, you have to see what kind of question is it. Some would be thinking arithmetic progression, but if you do this question using arithmetic progression, it is going to take a little bit more time if you use set theory in that, right? So first, what you need to do is you need to recognize the question. So once you recognize the question that okay, it's from set theory, then half of your job is already done. Then you just need to follow a structural approach which will help you to solve the question. So now let's move forward and let's see. Okay, now here's the smart student. She's asking me, how do we make out that the given question is a set theory question? Well, let me answer you this question. Let's see, this is a typical set theory question, right? In a class, 40% of the students have a pencil and 80% of the students have their books. Calculate the minimum percentage of students having both books and pencil. Now you already know that a class will already comprise of 100% of the students, right? The total number of students will always be 100%. So if you're seeing here that some of the students have pencils and some of the students have their books, and there is a possibility that students having books will have pencils as well, and students having pencil will have books as well. So if I draw it in a graphical manner, this is what I'll be getting. Let's suppose this circle here denotes people having pencil, and this circle denotes the students having books. So this area which is colliding in both of them is going to denote people having pencils and people having books, right? So this is a typical set theory question. So whenever two things are mixing together and there is a probability that both events might happen, then it is a set theory question, right? So let's move ahead and let's just understand what a Venn diagram is. So this is people having their notebooks, and this is people having their pencils. So there are three areas in which it is divided. Now let us understand what each area means so that we can use that approach in every question. So let us say this orange circle denotes people having notebooks, and this green circle denotes students having their pencils with them. So there are three areas which can come under this. Let me denote these areas by A, B and C. So A is something this whole area is denoting, B is something this whole area is denoting, and C is something this whole area is denoting. So if you want to calculate how many people will have only notebooks, so that will be denoted by A. If you want to say, okay, how many people are there who have only pencils, so that will be denoted by B. So if you want to say how many people have both notebook and pencil, that will be denoted by C. Similarly, if you want to say, okay, how many people have either a notebook or a pencil, that would be the sum of all these, because this has a notebook, this has a pencil, this has both notebooks and pencils. So that would be A plus B plus C. This is simple basic stuff, right? If someone asks you how many people have notebook or pencil but not both, so they should have either a notebook or a pencil but should not be having both. So it would be A plus B but not C. So that is A plus B. So if someone asks exactly one, how many of the students have exactly one of the things? They have either a notebook or a pencil, right? So that is again equal to A plus B, right? So if someone says how many of the people have at least one of the notebooks or pencil, so at least one of the things, all of three are having at least one of the things. These are the number of people having only notebook, these are the number of people having only pencil, and these are the number of people having both of the things. So that means A plus B plus C. Now if you see here, the answer to this is also A plus B, the answer of this is also A plus B. So there are a number of ways in which he can ask you the same question, right? Similarly, A plus B plus C here and A plus B plus C here. So there are a number of ways in which he can ask you the same question, which you need to understand and recognize, right? Okay, so what does this E denotes? This E denotes the number of students who have notebook, who have pencil, who doesn't have any of these things. So if someone asks, okay, how many students are there who have neither a pencil nor a notebook, that is denoted by a E, right? So this is very crucial in the question. We'll understand how this is crucial in understanding the question. Okay, so then, okay, the smart student is asking me, what if individual values are not given? Yes, if you already have all these values, then he might ask you anything, and you know, it's like an LKG question. But he has to make, the question maker has to make the question a little bit tougher. So what he's going to give, he's going to not give you the individual values. Very good question asked, Preeti. So he's not going to give you the individual values. Instead, he's going to just give you the values of N and the values of P, right? He'll tell you, just the way it was shown in the previous question, that 40% of the students own a notebook. So if 40% of the students own a notebook, that means that this notebook is this whole area, right? This notebook is this whole graph, which is nothing but number of people owning notebook is A plus C, and number of people owning a pencil, it's B plus C, right? So he is going to give you the whole values rather than individual values. If you have individual values, then the question is solvable using a little bit of algebra, and you'll be getting the question. Now let's see how he uses the big values, right? Now let's suppose he has given you the value of the set A. Let's suppose these are the number of people owning notebooks, right? That is A. These are the number of people owning a pencil, right? Let's say this is set B. So this circle over here denotes B, and this circle over here denotes A, right? Now let us assume that at least one of the students owns a notebook or a pencil. Now let's see. Now if you want to calculate A union B, now what is A union B? A union B is nothing but either A or either B. The meaning of this is also equal to either A or B. So he can ask you the question in any way, right? So how do you calculate that in terms of A and B? Now let me do one thing. Now let A union B, I need this area once, this area once, this area once, because this is whole A union B. So if I add A plus B, right, so I have added A and B. Now let's look at this area, the area in which both of them are together. Let me denote it by E. So if I denote it by E, so E has been added once here, E has been added once here. That means E has been added twice, which means that I would have to remove it once. So if I remove it once, then I'll get the exact value of A union B. So that means A union B is equal to A plus B minus A intersection B, right? So I hope everyone is understanding. This is pretty basic stuff, right? So let's see if we want to calculate how many people own exactly one of the things, either a notebook or a pencil. So if you look at from the graphical point of view, this area is needed and this area is needed. This area is not needed because these are the number of people who own two things, a pencil and a notebook. So that means you either need a notebook or a pencil. So how do you calculate exactly one in terms of A and B? So this is how you go about it. You add A and B, right? So once we add A and B, this area is added once, this area is added once, but this area has been added twice. But Do I need it even once? No, I do not need it even once. So that means I have to subtract it 2 times for me to calculate the value of exactly 1. So this is going to give me the value of exactly 1 in terms of A and B. Right? So I hope everyone understood. This is really easy. Fine. So if you want to calculate A and B, which is nothing but this area, that is A intersection B. Fine. So I hope everyone understanding how to calculate all these things, right? So let's see this question. There were 600 respondents in a survey who like at least one of the products, X or Y, right? And 420 like X. So what we need to do, there are number of people who like X is equal to 420, right? Number of people who like Y is equal to 450. Fine. So we have to find, oh sorry, there are 2 products here. How many of them like all 2 products? So I know there are total of 600 respondents. So I can say that the union of X and Y is equal to 600. Right? So I know X union Y, I know X and Y. So from this expression, I can easily calculate the value of X intersection Y, because this is what he's asking. How many of them like all 2 products? So this is equal to 600, and this is equal to 450, and this is equal to 420. So I just need to calculate the value of this, which I can easily calculate, right? So I hope everyone is understanding what I did over here. It was a pretty easy question. You just had to find out the values. The values were given for you for X and for Y and for X union Y. And you just need to calculate all 2 products, that is X intersection Y, right? So I hope everyone understanding. Okay. Preeti is asking me a question. So she's asking me that is the line in the previous question, like at least one product, superfluous? Well, this is a very good question, because this line completely changes the scenario in the question. So let's see what she's asking. Let's answer her question. Now this was the question that we did earlier. There were 600 respondents in a survey who like at least one of the product. Now she's asking whether this line is required or not, because I haven't discussed this lines in the previous slides. Yes, if the question had been, instead of this line had been like this, I would have deleted that line. Then I would not be able to make out that whether X union Y is 600 or not. It's pretty simple. Let me explain it to you. Now if, let's suppose, scenario number 1, wherein the question is where at least one of the person like either of the product, right? So if I say at least one like either of the product, that means number of people who do not like any of the product is 0. Right? So this is scenario 1. But what if I don't give you this line? What if I say, okay, there are 600 respondents, 420 like this, 540 like this. How many number of likes? All 2 products, right? So over here I do not know this value, because this line has been omitted from this question. So if I do not know this value, I will not be able to answer the question. Right? So I hope everyone is understanding what is the importance of this line. Whenever you read a question, do not forget to read this line. If this line is given, who like at least one of the product, that means A union B is equal to the total number of respondents. But if it is not given that who likes at least one of the products, then I would need to find how many people do not like one of the products, and then I can go about it. Right? So I hope everyone understood. This is a little tricky but very important for you to understand the set theory questions. Okay, so let's go ahead. All right, now she's asking me one more question, that what if there were 3 products? Very good question. So what if instead of in this question there was only X and Y, what if there was a 3rd product? Would that change? Yes, it would change drastically. Now let's see how does that happen. Okay, now this is a typical question. There were 600 respondents who like at least one of the products, X, Y or Z. 220 like X, 250 like Y, 310 like Z, and so on and so on and so on. So he's asking you how many of them like all 3 products. So now this this question becomes a little bit tricky, but not tricky until unless you know how to solve it. Now let us understand, whenever there are three aspects in a set theory question, usually you'll get a question out of three aspects only, especially GMAT students. You'll get you won't get a question with only two aspects. So let's see. So this is the question in which you always have to make the diagram like this, because this covers all the scenarios, right? So this is this number of students liking product X, number of respondents liking Y, number of respondents liking Z. So this is how you'll make it, right? Okay, hold on, she's asking me one more question. Okay, yes, yeah, she understood it. Fine, so let's move forward. So this is the typical description of that. Now let us understand, just the way we did in two aspects, let us understand each area one by one. So if I ask you how many of the respondents like only product A, that would be this area over here, only product X would be this area over here. Similarly, only product Y would be liked by B, and only product Z would be liked by C. Then if you have to calculate how many people would like product X and product Y, that would be this area, D plus G. But if I ask you product X and product Y but not product Z, so that would be just this area D, because this G contains product Z as well. Similarly, if I ask you Y and Z but not X, that would be F. Similarly, X and Z but not Y, that would be E. So this is the way it is. And X and Y is equal to D plus G, X and Z would is E plus G, Y and Z is F plus G, right? So all three is equal to G. So this is pretty simple stuff. Now let us understand, okay, if someone asks X or Y but not Z, so you understand the difference between and or. And means both have to come. Or means either of them can come. So X or Y but not Z means A plus D plus B. Y or Z but not X means B plus F plus C. X or Z but not Y means A plus E plus C. So this is this way, right? So this is simple basic stuff. If he gives you all the individual values, I think you're sitting for a nursery exam, right? He won't be giving you that. He wants to make a question a little bit difficult. Okay, so X or Y or Z is all of them, or it is also equal to at least one. So exactly one means who like exactly one of the products, that is A, that is B, and that is C. Now this D, E and F is nothing but exactly 2, right? Similarly, exactly 3 is nothing but G. Fine. Now what is the difference between exactly 1 and at least 1? Exactly 1 means they like exactly one of the products, and at least 1 means that minimum number of products liked by any of the respondents should be 1. So in at least 1, all of them are going to come. Okay, now let's move forward. At least 2 would comprise of D, E, F, G, because they like at least 2 of the products, right? Okay, now the question comes again. Now let us not wait for Preeti to ask that question. Now let us see, what if the individual values are not given? What if I've been given that X, number of people who like X is this, number of people who like Y is this, number of people who like Z is this. Now let us derive those things. Now what is at least 1? What if these individual values are not given to you? So what if this at least 1? Okay, now at least 1 comprises of all the areas, this, and this. So let us calculate how to calculate at least 1. So what I do is, so I'm not asking you to cram this formula, I'm showing it to you how to derive it, because you can derive it on your own in your exam as well. It's pretty simple. So if I add A, B and C, right? So I've added A, B and C. That means this area has been added twice. This area has been added twice. This area have been added twice. So I need to remove it once, because I need it once in my formula. So what I do is I remove all of them one time. So removed one time, removed one time, and removed one time. So I'm not over yet. Why? Because let us concentrate on this area. Let me call it E. Right? So this area is part of A, that means it has been added here. This area is a part of B as well, it has been added here. This area is a part of C as well, it has been added here, right? This area is part of A intersection B as well. That means it's added here. It's basically part of every area because it's common to all. So this area have been added 3 times and removed 3 times. That means the net effect of this area is 0. So for me to have an efficient formula, I would need to add it once more to get the complete formula. So the complete formula would be adding A intersection B intersection C. So what is at least one, guys? It's A plus B plus C minus A intersection B minus B intersection C and minus C intersection A plus A intersection B intersection C. Right? So this is how you calculate at least one. So till right now you must have been taught in your high school, okay, this is A intersection B, A union B union C, right? Now let's move forward. Let's actually find something really good. Now let's see how to calculate at least 2. Now looking at the previous slides, you must have understood what is at least 2. At least 2 is nothing but this area plus this area plus this area plus this area, because these are the number of people who like at least 2 of the products. Now let's see how do we calculate at least 2. Now what do I do is, so let me start with adding A intersection B, B intersection C and C intersection A. Let me start doing that way, because I don't need this areas at all, so I won't be adding A, B and C. So I added A intersection B plus B intersection C plus C intersection A. Now let us look at this area once again, the E guy. So E has been added here, E has been added here and E has been added here. So that means E has been added 3 times. So how many times do I need E? I just need it once. So that means I will be removing it 2 times. So this is what is going to give me a at least how many people would be liking at least 2 of the products, right? So I hope this is understood. This is now you'll be deriving the formulas on your own, right? Okay, now let's see how do we calculate exactly 1. So what do we need in exactly 1? We need this area, we need this area and we need this area. So okay, I would recommend you to pause this video and start doing it on your own. Okay, all right, so let's start it. So what I do is I add A, I add B, I add C, right? So I've added A, I've added B, I've added C. So this area has been added twice, this area have been added twice and this area have been added twice, but I don't need it even once. So what do I do is I'll remove them 2 times, right? So I remove them 2 times. So I have removed them 2 times, right? Okay, good. So now let us concentrate on this guy once more. So this guy have been added 3 times here, but it has been deducted 6 times here. 3 times it is added here and 6 times it is deducted here. So that means it has a net effect of minus 3 times. So how many times do I need it? I don't need it even once. So I have to add it 3 times for me to get a complete formula. Right? So guys, mind my handwriting. This is A intersection B intersection C, right? So this is how you calculate exactly 1, right? So it's pretty simple. You don't need to learn this. I haven't learned this till now. I'm just calculating, writing in front of you. Okay, so let's see the last one is exactly 2. How do we calculate how many of them are in exactly 2 zone? So this is what we need, this is what we need, and this is what we need. Now let me be a bit quick, because I suppose you will be understanding the way, the logic I am following in every step. So what do I do is I add A intersection B, I add B intersection C, and I add C intersection A. So I add all 3 of them. So let's concentrate on this guy once more, right? This guy is the main guy, right? So he has been added 1 time here, 1 time here and 1 time here. That means a net effect of how many times? 3 times. But how many times do I need him? I don't need him even once. So what do? I remove him 3 times from the formula. So that means this is nothing but gives me the value of exactly 2. right? So I hope everyone understood this, right? Now we've done a lot of stuff. Let's just put all of that into some questions, into the same question. So there were 600 respondents in a survey who like at least one of the products A, B or C. 220 respondents like product A, 250 like B, and 310 respondents like C. 84 like both A and B, 70 like both B and C, 16 like both A and C. How many like all three products? Now you'll see, oh my god, lots of information. But you see this, if you understand the expression that I've told you about A union B union C, you'll understand exactly that what he's asking for. Now there are 600 respondents. Our first step is to find what is A union B union C. That is our first step. Is it equal to 600 or not? And which line tells us that? Yes, this line tells us that. If at least one of the products is liked by A, B or C, that means there are no people who like neither like A, B or C. That means the total number of respondents who like at least one of the products is 600. Now he has given us that 220 people like A, that means A is equal to 220. Similarly, B is equal to 250. Similarly, C is equal to 310. And what has he given us? He's given us value of A intersection B. So what is A intersection B? That is equal to 84. What is B intersection C? That is equal to 70. And what is A intersection C? That is equal to 60. So this is everything. This is all I know, what he has given me through the question. Now what he's asking us? He's asking us the value of E, the main guy, A intersection B intersection C. Now if you remember this expression from the previous question, from the previous part of the video, you would be able to solve this question pretty easily, right? So if you remember this expression, this is the expression of at least one. So you know the value of this, you know the value of this, the value of this, the value of this, value of this, value of this, value of this. Just substitute the values of all this, whatever you know, into this equation, and you'll get the value of A intersection B intersection C. So I hope everyone is understanding how we are able to solve this question. I'm not solving because that's the algebra part, the boring part for me. Fine. So let's move forward. Okay, now let's see this question. Company X has 3 departments: Visa, Education and Reception. Visa has 300 employees, Education has 400 and Reception has 450 employees. 30 employees belongs to both. Now if you're seeing, if you what you need to do is you need to denote them some figures. Let me say this guy is A, this guy is B, and this guy is C, right? So it has 3 departments and Visa has 300 employees. That means A is equal to 300. Education has 400 employees. That means B is equal to 400. Reception has 450 employees. That means C is equal to 450. 30 employees belongs to both Visa and Education. If they belong to both of them, that means A intersection B is equal to what? Is equal to 30. 40 to both Visa and Reception. So that means what is Visa? Visa is A and Reception is C. So 40 to both of them. And 50 to both Education and Reception. So 50 to both Education and Reception. So that is 50. Now he said that 20 employees work in all 3 departments. So 20 employees work in all 3 departments. So this is that. So calculate number of employees working in at least one of the departments. So how do you calculate that? You calculate number of people working in at least one of the 3 departments. Now there must be a question rising in your mind. What if neither of them works in any of the departments? So you can see there, the company X has only 3 departments. If they do not work in either of the 3 departments, that means they're not working in company X. So you can safely assume that A union B union C would be equal to this just apply the expression here, a plus b plus c minus this minus this minus this and plus this. You will get your answer. So I hope everyone is understanding. You just need a structured approach and you will be able to find the answer, right? So let's move forward. What if he has asked you calculate how many people are working in exactly one of the departments? So you can easily calculate that because you know all the things, right? Now let's see this question. A survey was conducted to 120 employees at company X and was asked about their bank information. The following is the summary of the information gathered. 24 employees have account in only HSFC Bank. So whenever you see this keyword only, that means it's only A, right? So whenever you get now earlier we were doing questions where we were knowing only the big values, right? The value of A completely, value of B completely, but over here the values are distributed. So once the values are the small values are given to you, it's always recommended that you draw the diagram, right? So let us denote this by A. Okay, let's say this is HFSC Bank, this is nothing but your WIS Bank, and this is nothing but your ABC Bank. Fine. Okay, now let's see what it's saying. Now first, the very first step is to try to fill the information into the diagram, then go about try to filling the information which is not in the diagram. So 24 employees have account in only HFSC Bank. So this is HSFC Bank and this area is the only HSFC Bank area. So 24 people are right here. Right now 15 people have accounts in both bank ABC and WIS. So what is both ABC and WIS? This is this whole area. So let's just forget about it and try to fill in the individual information. 12 have accounts in banks H and W but not in A. So HFSC and WIS but not ABC, which is nothing but this area. So 12 people are right here. Right, so the next is 50 people have account in HFSC. That means this whole is equal to 50. And then what is saying, 8 people have account in HFSC and ABC but not WIS. HFSC and ABC but not WIS. So that is equal to this area, and this area how many people are there? 8 people are there. Now if you see over here completely, this whole area, you know, it's 50, this is 24, this is 12, and this is 8. So if you sum all of this, this is 24 plus 8, that is 32. 32 plus 12 is equal to 44. But this whole area is equal to 50. So that means this area must be 6, so that this whole area comprises to be 50. So even if you add, it's gonna come out to 50. Now let's use the information that we have left. 15 have accounts in both banks ABC and WIS, ABC and WIX. So that means this whole area is equal to what? Is equal to 15. That's what he's saying. And if this area is 6, so this area will be 9. And this is what he's asking. He's asking how many employees have accounts in banks ABC and WIS but not in HSFC. So this is number of people is equal to 9, right? So I hope everyone is understanding. This is whenever individual values are given to you, you just need to put the individual values inside the diagram and don't need to use any other expressions. Fine. Alright, so I hope everyone understood. Okay, so yes, as the smart student will do, I will practice for right now, and if you want to clarify anything, yes, you can contact me at this email address. You can definitely contact me at this email address. I'll reply to you within if it is normal hours, I'll reply to you within 1 hour or 2 hours. Give me 24 hours, the maximum time I'll reply you, right? So what you need to do is you need to practice some questions, get some practice questions, buy some books and do some set theory questions, right? So thank you very much. This was the first video on set theory, wherein we understood the concept of set theory and this, how to solve some questions on set theory based on 3 parameters and 2 parameters. In the coming videos we'll be discussing the maximum minimum phenomena and the tree approach that we'll be talking about, wherein more than 4 aspects are there, right? So this is for it right now. Thank you very much and see you next video.